Hello, yeah. So today we are going to talk about computer organization in a binary representation method. Here we are going to learn about bit, byte, binary, decimal, and hexadecimal number system. Okay, so in this case, we are going to learn about what is bit and byte. So what is a bit? So bit is basically a smallest unit which comprises of the memory unit. Basically, it is used as a unit for memory. So 8 bits is equal to 1 byte, right? So it is just like 1 kilogram is equal to 1000 grams. Here we have 1 byte is equal to 8 bits. And it is denoted by a small letter p. Please remember it is denoted by small letter p. And byte is denoted by capital B. So never get confused by this. And when you write 1 bit is equal to 8, 1 byte is equal to 8 bit, it can be stored a single character. So 8 bits are required to store a single character. Now what is a number system? So when we call about decimal number system comprises of 10 digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 to represent any number. All the other numbers are combination of these 10 digits. Whether it is 188 or 1958, all are same. Correct? So all these things are basically comprises of these 10 digits. So that is why we are calling it as a decimal number system. So we can call that it is a base 10. Now when we talk about this, you can see here we can write in the term of power of 10. For example, if it is 1958, I can say it is 1000 plus 900 plus 50 plus 8. So it is 1958. Let us come to this point. Example of number system will be like this. And if it is number 0.627, which is written in decimal part, so it means it is 627 upon 1000. So it can be 0 0.1, 0 0.01 and 0.001. It means power will be negative. Now in the same number, fractional quantities can be taken. So it is known as 110, 100, 1000. Okay. Now, apart from that, imagine that we need to understand a quantity represented by 6275 base 10. So we can easily write here 6275. You can see here 6275. Right? Now, we have a binary number system. Binary number system is exactly same of decimal number system. Only thing that it has only two digits, that is 0 and 1. So all the number will be power of 2. So if 2 raised to the power 0, it is 1, 2, 2 raised to the power 2 is 2, 1 is 2, 2 raised to the power 2 is 4, 2 cubed is 8, 2 raised to the power 2 is 16, 2 raised to the power 5 is 32, 2 raised to the power 6 is 64, 128. So an example of number system is like this, 10110 base 2. So the base number cannot omit the binary number system, right? Okay. So there is an example given here. This is a number which we need to. So I have prepared one Excel sheet for it. Now here is the number in which I am going to write a number. Now suppose let us see that binary number. Suppose my binary number is let's say it is 11001110. So you can see here this is my number. Okay, 110. So my answer is coming here as 102. And this is my numbers in which decimal is converted to binary. Let's say it is 102. So am I getting the same answer? So you can see here 1100110, 1100110. So this is the conversion system. Okay. Now let's go here. So there it is given an example. 46 divided by 2 gives you 23. Let us take here. I have taken the number 46. So my 46 is divided by 2. It gives me 23. So this is 23. So I'm going to compare this number here. So I'm getting here, okay, remainder as 0. Correct? Now I have taken this 23 divided by 2. This 23 is divided by 2. So I get 11.5. Now 11.5 means this number is not divisible. So I have taken a floor of that number, so that it is 11, and if this number is compared with this is greater, then its remainder will be 1. Then 11 divided by 2, 5.5, round it is 5. Yes, so in the same manner I am getting this number here. Okay, so my number is here now. At that time I am getting this number. So let's say if I am writing here, my number is 101110. So what I am going to do, I will put it here, and my number is C. So 46, and this is the 46. So I'm getting the same number. So this program basically are designed for binary to number, binary to decimal, and this is decimal to binary. Okay. So basic rule is just like this. So you can easily find out then what is the 8-bit number or 6-bit number. Let's see here. So if you call 1, 2, 3, 4, 5, 6, this is a 6-bit number. This is 7th and this is 8-bit. Okay. So if your number comprises of like this, so it is 8-bit number. So what will be the highest value of 8-bit number? So you need to put all ones here. So you can see a 8-bit number consists of 255. So it will be 0 to 255. So if I put here 255, I'll get all ones. You can see here. And if all zeros, so it means total number of digits it will take 256. Correct? Right? Now binary number system and negative number system. Now if you suppose want to find a negative number system of a binary number system, then you have a solution for it. First of all, what you are going to do, suppose my number is minus 42, no 43. So simply you find 43 of this. So your answer will be around 101011. Now you can see how many bits are here. 1, 2, 3, 4, 5, 6. Correct? 6. So I need to make this number as 8-bit first. So for 8-bit I will write here 00101. Okay. Now what I am going to do, I am going to convert all the zeros into 1 and all the ones into zeros. So this is my ones complement. Because it is Excel, so it is, you cannot see right now. So what I am going to do, I have to add 2 zeros, so that 2 zeros will be 1. From there, this 1 will be 0. Okay, this one will be 0. This 0 will be 1. This 1 will be 0. This 0 will be 1. And then 0, 0. So this is my number. And after that, I have to add 2's complement. So I need to add plus 1 here. So what I am going to do is equal to this plus 1. So you can see this. So this is my number. Now let's see what is this number. So to know this number, I need to, okay, now this number, please remember this number, the last bit, this representing a sign of negative because it is 1. So I am going to write here this number. This number is 1, 1, 0, 1, 0, 1, 0, 1. Okay, this is my number, but this is my sign bit, so I am not going to take this. So 85. So minus 43, and it is 85. So please add this number. So this is equal to this minus this. So you can see it is 128. So total is 128. So range is minus 128 to plus 127. This is the okay. Now, okay. So this is very good examples are given in the book. So now there is unsigned number and signed number. So in binary number system, we have used to separate a binary. So fixed point representation like it is 0.5 and 0.12. So in case if you have a number which is divisible, which is at the decimal place, so 0.035. So you need to multiply it by 2 unless and until you are not getting the value. So I am getting here 0101. Signed basically which has a symbol plus minus. Right? Okay. So this is the example, write the representation of minus 4.25 in a fixed point. So what I'm going to do, I'm going to take 4 as 0, 0, 1, 0, 0, 1, 0, 0, okay, and 25 will be 0.10. And now after taking what I'm going to take, I'm going to take the first complement, which is 1, 0, 1, 1, 1, 0, 1, 1. Then I have to add 1 of it. As soon as I add 1, if this 1 plus 1 is 0, this 1 plus 1 is 0, this 0 plus 1 is 1, 1 as it is, and this is the result. So this is the real function. Then we have a hexadecimal number system. So hexadecimal number system consists of 16 digits from 0 to 9 to A, B, C, D, E, F, where A represents 10, B represents 11, C represents 12, D 13, E 14, and 15. Base 16. So if you go with that, 16 is to the power 0, 1, 15 is to the power 16, square is 256, cube 196, and 4 is 635, 36, 65,536. Solution is exactly same thing you have to do. You need to divide by 16 unless and until you are not getting number less than 16. Okay, correct? The same procedure you are supposed to do. Returning the value of 810. So A is 810 means it is the binary number which is represented. So 8 plus 23 and correct. Right? Then we have another type of conversion here that is called that is called hexadecimal of binary, that is a simple one. Then we have a data representation. So all the data can be represented in the form of 2. So 2 raised to the power n. N is the number of bits in its common bits. Suppose it is 8 bits, so it means n is 3. So you can see here distinct bits. Okay, so integers. So we have integer here. So integer it represents that the number of bits in n, n is between 1 to 8. The relationship can be used for different bits. So example of positive integer are like this. Use complement method can give us negative numbers. There is a character. So characters are like this. It stores value from 0 to 127. You can see here this is the ASCII character code. After ASCII character code we have strings. Strings consist of 8. Each character is of 8 bits. So it depends on how many characters we have. It will be a UTT like 8 integer. And it is string is 5 characters. So it will be around 40 bits. Color, you can see here color 1072.768. All these are made up of the number system which follows the number system thing. Okay, now this is the image enlarging that becomes apparent to the number system. So RGB, it is basically representation of hexadecimal number system. So the range of hexadecimal number system is 255. A 6-digit hexadecimal is from 6 times 0 to 6 times 10. Right, so we have discussed different type of distinct color in it. A lot of good examples are given in the book. Now in the next video I'm going to talk about simple logic gates. Okay, so very soon I'm going to update it. Thank you, and please like, subscribe my channel, share it. Okay, so I know that this video is little in hurry, but just it is for the revision purpose, so please go through it. And if you have any suggestion or comment, please give it to me. Thank you very much.